Right. Yeah, that's something for there. Right. Anyway, so I was working on the this previous rotary system, right? You know, using my anti-drag generator, and I kind of put it aside. Then I had a thought, actually, I can take out all the magnets on the stator on this, and then put them into the segments which are interchangeable, which I can take out the segments on these. Then I can use this as a magnet motor, because instead of the magnets populated in the actual stator, the magnets would be in the rotor. And after 3D design some, well, obviously not these magnets, the round magnets, I mean. So I would make some new segments that would go in here, right? And then I would use the round the round 20mm neodymiums in that rotor to be actuated against the new segment designs, which would be as the stator drive force for the such as something like that, right? But these will be mounted in a new, instead of the canopies which I use for the coils for this thing, obviously it won't be any coils on here because it would be turned into a magnet motor instead. So instead of me having to 3D print all this lot and everything and a whole new design, I could still use these rotors, you see, for the magnets, which would be in here in these segments instead of the things. So I just pop these out. Then I could mount these stators because they need to have an inch gap. So we actually have about an inch gap. So maybe a little bit too much. Maybe there's 2 inches there. But yeah, if I made new legs that would these new brackets, if I made them so I could fit these things in, we would slot them in, sort of, right? So that they could actuate against the magnets that are in the rotor, right? You get the idea? So that's what I'm thinking of doing, because it would save me having to print a whole bunch of new plastic frame, and yeah, it just makes it, you know, I thought it's a simple solution to making a magnet motor out of this, because then I don't have to print everything, and I can just pop these segments out, put magnets in them, and then we could actuate them with the, then I don't waste a lot of plastic, and we can also test the feasibility and functionality of the design. Obviously this has to be about an inch gap, about there, between there and the, well, where the magnets are in there. So yeah, so that's what I'm thinking about doing. So yeah, let me know if you think that's a good idea. I think so myself personally, because it saves me having to print a whole new rotary drum system, because I can just print the segments that go in there, because as you know, these segments pop out. They're interchangeable, because this is why I've got all these segments lying around here. They just pop out, you see. And I've also got these other segments sets, and it means that my rotor system can use whatever segments I want. So it's a bit like Lego, you see. A lot more segments down there. But yeah, we have to make the segments with the obviously the right orientation for the magnets to be held in there. So I would probably put the magnets in the middle somewhere. So the segments have to be changed so that we have a row of magnets, 20mm magnets, all going down here. And then I can have another row in the next section down there, and then we have a continuous, actually on both sides, don't forget, so we have them on the back as well. So anyway, it's a simple solution to something that would have been otherwise quite expensive to 3D print everything. So I don't have to 3D print this is, obviously it's a much smaller diameter than the original magnet motor design that I was thinking about, you know, I was in the rotor, but which is in bits all over the place actually. So I mean, obviously that's part of the other magnet motor I was working on there. I thought, well, rather than trying to change that, because that would be too difficult, because I haven't designed it where it's got removable segments and it's a lot larger diameter. We don't really need a larger diameter, because the smaller diameter with these particular configurations will actually work better for this, because the entry and exit points work best when we're coming in at a steeper angle, rather than when I say steeper angle, I mean instead of the rotor coming in at this arc, right, and this particular arc, we're coming in at this sort of arc, which is better for this particular segment, because as I've been testing with by holding my magnets against it, it works best. There's least amount of entry resistance when I'm coming in at this angle and going out at this angle. Whereas if I come in at this angle, there's a certain amount more resistance, but I can tweak that obviously by adjusting the magnets that are on the end to compensate for that. But yeah, anyway, it's better when it's coming in at this sort of arc like this instead of that. Yeah. Anyway, you get the idea. I think just a quick update. Hope you're alright, and see you later. Bye for now.